We do know that it's symmetric across the line y equals x, so you could graph y equals x and try to reflect it across that line. The easier option might be even to just take ordered pairs and reflect them. So we know this is the point -2, -2. So when you flip x and y, it stays -2, -2. This is -1, 0. So when you flip it, it goes to 0, -1. Here is 0, 1, so it would become 1, 0. This is 1, 2, so it would become 2, 1. So you can either reflect the graph or actually find ordered pairs and reverse x and y. And so it should look like this. Did we get that? We are now going to start finding inverses. So, in finding an inverse, there's 4 steps that we're going to go through. First thing is, if it's written in function notation, change your f of x to a y. We want it to be y equals. Then we will switch x and y, because that's what an inverse does. It reverses x and y. And then we want to turn it back into our typical function notation. So we have to solve for y, and then at the very end, instead of y equals, we'll put f inverse of x equals. And that's what tells us it is an inverse. So if I ask you to find the inverse of this function, step 1, instead of f of x, we will write y. Okay, step 2, what do we have to do? So instead of where we have a y, we're going to put an x. Where we have an x, we're going to put a y. Then we want it to be y equals, so we have to solve for y. So we can subtract our 3, divide by 2. And final step, instead of y, what do we put? And that's what tells us it is an inverse. So that's the equation for the inverse. I also asked for domain and range of both the function and the inverse. So you could label like function, do domain and range underneath, or I usually just do D for domain and a subscript of F to tell me the original function. Domain is asking what x can be. So we know that if it's a fraction, the bottom can't be 0. If it's an even root, it has to be a positive number underneath. The original function, it didn't have a fraction, it didn't have a radical. So what's our domain? It's just a line. X can be anything. Now the range of the function is a little bit harder to think about without a graph. But, lucky for us, we do know something else. The domain of the function is equal to what other thing? The x's in the original become the y's in the inverse, right? So the domain of the function and the range of the inverse are the same. And I'm going to put f -1 as a subscript. So domain of the original function is the same as the range of the inverse because you just flip the x's and y's. So the range of the function is the same thing as the domain of the inverse. We talked about this yesterday, but we hadn't used it yet.
How do we find the domain?
So domain of the inverse, we look at our inverse. It's a fraction. Does 2 ever equal 0? No. So we know in a fraction the bottom can't be 0. But if the bottom isn't 0, then what's it going to be? So it's a lot easier to find domains than ranges. And that's what we can look at. We can just do the domain of both the original and the inverse. Any questions so far? Let's do a more interesting one. Alright, so to find the inverse, first step, instead of f of x, we write y. And then what do we do? So my y becomes x. Both x's become y's. So you flip the variables. Alright, I have to solve for y. If I want to get rid of a fraction, we know we can multiply by the denominator. So if we multiply the y minus 1 on both sides, it gives me xy minus x equals 2y plus 1. What should I do at this point? I'm trying to get y by itself. So we basically want everything with the y on one side and everything without it on the other. So we can do that a couple ways. We can move all the y's to the left or to the right. Does it matter which way? No, as long as you take the other step to the other side. So
Should we divide first, or should we subtract the 1 first?
we can't divide because we still have 2y, so I need those together first. So even if you guys said subtract 1. If I do that, it moves the 1 over, but what else would I have to do? Would that put all my y's on the same side? So I would also have to subtract the xy. So that gives me negative x minus 1 equals 2y minus xy. Now, both of those terms have a y, so what can we do? We would normally try to combine them. But unfortunately, they're not true like terms because one has an x in it and one doesn't. So I can't actually put them together into one. What else can we do if they both have the same thing? I can't combine them. Not yet, but you're getting closer. We want to set it up so that we can divide by something. If we want to divide, we need a single term. So what we're going to do is factor out the y. If I take out the y, then it's y times 2 minus x. And now, could we divide to get y by itself? Because now it's y times something, so we're going to divide by 2 minus x. So that gives me negative x minus 1 over 2 minus x equals y. So final step, instead of y, we write f inverse of x. Now we need domains and ranges. And I know the domain of the function is equal to what other thing? The range of the inverse. Make sure you put these subscripts. If you just say d equals r, that's really not correct. I have to know, we have two different functions. I need to know the domain of which one is equal to the range of which one. So the domain of the function equals the range of the inverse, and the range of the function is equal to the domain of the inverse. Okay. So if I do that, if I look at my original function, we had a fraction. We know that in a fraction, the bottom can't be 0. So I know x minus 1 can't be 0, so x can't be 1. How do I write that?
From negative a to one, and then parentheses.
When I'm looking at the range of the function. It's hard for me to look at this and know the range, but I could go to the inverse. If I want the domain of the inverse, the denominator can't be 0, so x can't be 2. So I would write that as negative infinity to 2 union 2 to infinity.
Is there ever gonna be brackets for like the parentheses or anything?
Only if it were like a radical. If it were a square root, you would have a bracket.
So how come you do the 2 on the range and not the 1 again?
Because the range of this original is asking what y won't hit. So there's a couple ways telling it. If you think back to our horizontal asymptote rules, this one has a horizontal asymptote at 2, so it's not hitting 2. But the easier option is to realize the range of that is the same as the domain of our final answer. And so if I look at that inverse, I can tell that the bottom can't be 2. You're welcome. Other questions? We'll do this one together, then I'll give you guys one. So yesterday we said the square root function, the square function wasn't 1-to-1, so it doesn't have an inverse. And now I'm asking you to find the inverse of it. Why is it okay to find the inverse now, when I told you it wasn't 1-to-1 yesterday? What did I change on it? My function is still x squared, but I added in x is greater than or equal to 0. If you think about the graph, we know it's a parabola, but if I'm telling you x is greater than or equal to 0, that's only including half of the parabola. If you only have half of it, is it 1-to-1? Yeah, so that's why we're able to find the inverse. Okay, so we write it as y equals, then we flip x and y. Now if I want to solve for y, how do you get rid of a square? Square root. When you add a square root, we always do plus or minus, but I already know that this is positive, so do I need the plus and minus here? No. So your y equals the square root of x. So my inverse is the square root of x. Domains and ranges. So domain of the function we know is the same as the range of the inverse. The range of the original function becomes the domain of the inverse. So if I'm looking at the original function, x squared could be anything, but I told you it was greater than or equal to 0. So how would I write that? It's because of the equal to, the 0 gets a bracket. Okay, range of the function, if you have the graph, you might be able to tell it. Otherwise, you could look at the inverse. We know that if you have a radical, whatever's under the radical is greater than or equal to 0. So again, we get 0 to infinity. Any questions on that one? Why don't you guys try this one? Similar to the example. first step, instead of f of x, we write y. Then we switch x and y, so this becomes an x. Both of these become y's. So if I'm solving for x, we can multiply y minus 3.
Teachers, at this time,
You would. All right, so if we distribute our x, now what do we need to do?
Get your Y's together.
All the y's on one side, everything without it on the other. So I'm going to subtract over my y and add over my 3x. You could have done it the opposite way though. It's totally fine. Now what do you do? And then you divide. If you move things to the opposite sides, your signs are different, but it is equivalent. So my inverse, based on the way I did it, I get 5 plus 3x over x minus 1. If you moved it to the opposite side, you would have negative 5 minus 3x over 1 minus x. And those are equivalent. So either is fine. Domains and ranges. We know the domain of the function is the range of the inverse. So if I look back at my original function, what can x not be?
3, -5.
So for just this one, we're going to say negative infinity to 3, and 3 to infinity. Then we know the range of the function is the same as the domain of the inverse. So if I look at my inverse, my denominator, 1 minus x, can't be 0, so x can't be.
thank you all for your participation in the earthquake drill today. You're all clear to resume class.
Yep, we're all good. Okay. Did you guys get your domains and ranges? Any questions on that one? Do we need another example like this? The last two slides I have, it's really not a lot of math, it's just kind of testing if you understand what an inverse does. So this one says f of x is the number of cars that can be built for x dollars. So what this tells me, x is dollars, f of x is number of cars. What does f inverse of 1,000 represent? This is in the actual function. When you do the inverse, so f of x, if you wanted, you could even write that as a y. They're the same. When you do the inverse, what happens to x and y? They switch. So x would become the number of cars, and your y, or your inverse, is the dollars. So when I am asking about f inverse of 1,000,
Would be $1,000. How much you can build for $1,000, correct?
this is the x of the inverse. So when you look at the inverse, x is the number of cars. So this is saying we have 1,000 cars. The whole thing is like your y. What does y represent? The dollars. So f inverse 1,000 is the cost of 1,000 cars. It flips what x and y mean. So because it's the inverse, the 1,000 is the x of the inverse, which is y in the original. So it's giving us a number of cars. Then the whole thing, it's spitting back as the cost. So it just flips our order pairs. Those can be a little bit harder to think about. So if you want to write down kind of like what I did, writing down what X and Y represent, I think that's a big help.
So, but how do you, one, it says f of x is the number of cars. Why is it,
Because
why is
this,
it the opposite? Like, I mean, I
is-
know in the inverse, why is it the opposite?
yeah, and that's what we're interpreting, what the inverse means. So I gave you f of x in the original function, that was the number of cars. But that, when you do the inverse, that becomes your x value. So because it was f inverse of 1000, this is x in the inverse function. And in the inverse, x is the number of cars. Any questions there? And the last one, I think there's a MathXL question like this. So it tells me the graph of the function is shown. But I want the following. So this is f of x. But I'm asking you questions about the inverse. Okay, so think about what happens. When I say f inverse of 2, that means in the inverse, 2 is the x. So in the original function, 2 was your y. So what this is telling me is find x when your y is 2, because my graph is the original function. So if I look at my graph when the y is 2, what's my x value? Because that point is 0, 2. So when the y is 2, my x was 0. So if I say f inverse of 3, because this is the graph of my function, I need to find x when the y value is 3. So if I go when y is 3, that's here. What's that point? So my x is 7. F inverse of 9 means find x when y is 9. So when my y is 9, what's my point? So my x value there is 9. So it's a little bit backwards because I'm asking questions about the inverse, but the graph I gave you was the function itself. So you have to flip x and y.
How does that still work when it's a negative? Like that?
That's what just tells us it's the inverse, that x and y flipped spaces. So, you know, you're thinking, when I say f inverse of 2, we know in the original it looked like this, but when you do the inverse, you change the order. So when I say f inverse of 2, the 2 is the x of the inverse, you're finding this one, but on the, when you go back, they change direction. Because inverses are opposites. The x and y just reverse. Other questions? You guys had that MathXL assignment from yesterday. You have the rest of the class to work on it. It is